Thank you, Simran, for this warm introduction. So, without any further delay, let's start the session. Okay. So, please let me know once you guys see the screen.
Yes, we can.
Okay, that's nice. So, this is kind of an introduction to RAG and advanced RAG, you know. So, first and foremost, let us discuss about what LLMs can do so that we can get a grasp of why do we need this RAG thing, right? So, LLMs are basically prediction machines, like machine learning systems that can generate human-like text because they're trained on like huge data. They can do that. So all the things they can do is generate text, the next token, in sequence, right? So like they have some logical reasoning capabilities as well, right? So this is the two things that LLM can do, and primarily they can only generate text in a sequential manner due to their architecture that they are created with. So the one thing that LLMs can't do is say anything, mostly say anything out of their training data. So if an LLM is trained on, let's say, this X data, it cannot tell anything out of this data. So when you either ask this LLM something out of this training context, what the LLM will do is either it will tell that I don't know, right? Which ChatGPT, Google Gemini, all of them do. We have seen that, or else they'll start hallucinating and tell us something made up story about what all we have asked, right? So this is the behavior of a typical LLM. So any LLM given at a moment can only generate text from its training data, else tell no, I don't know, or hallucinate. So there was a big problem. So there was a big problem that they are firstly limited to training data, and if we need something out of the training data that the LLM wants to say us, can't be happening, right? So there are two things. Okay, so there are two branches that I can derive from this to kind of customize the LLM to tell me from a data source. So the two things are, for example, if I have a data, so I want that my LLM only inferences this data and tells me. Okay, so there are two techniques for that. One is the RAG technique that we are going to discuss today. One is the fine tuning, right? So fine tuning means loading the pre-trained weights and biases or the parameters, what you call the model, and retrain it with this existing data. Right. So the problem with that is, first, this data needs to be, customized kind of for the use case that we have. If it's a chatbot, it needs to be in a chatty format, right? So question answering type of format. So formatting and getting this data into that format, that is the first difficulty that we have. The second thing is, okay, if we have this kind of data with us, we can easily fine tune the LLM. We can easily fine tune the LLM. But now, if I want to change the data, so this data is, let's say, it is changing every week. Okay, or let's say this is the monthly report of a company, finance report. I can't just go ahead and train on each and every month's data for a model, right? Because first of all, this model is huge model. Okay, so there are multiple things in place to fine tune, like quantization and everything. And so we have to do that, and we have to again rephrase or reframe this data accordingly, and then train this model. So training is a tedious process, very expensive process, time consuming, right? So fine tuning for specific use case is only feasible if we can get the data first of all. Secondly, if we have the resources, and thirdly, if it's a long-term game that we are playing, right? I'll give you an example moving ahead where fine tuning can be useful, right? But the second thing is the RAG. Okay, RAG is called Retrieval Augmented Generation, and this this enables the model to reference this data, and this data does not be in a like it's not needed that the data is kind of specialized for the model, right, for tuning. So it can be a PDF, it can be a Word, it can be an Excel sheet, it can be a code base, right? So you don't need to mostly you don't need to like redo this data or wash this data down, right? Like you need to do in fine tuning. So RAG is a computationally less expensive approach, a kind of a better approach if this is a periodically changing document over here, right? So in that cases, you can use RAG. So that's the thing where RAG comes into picture. So very important that we need to know the difference and the scenarios where you can fine tune the model and use them, and when you can use RAG. Right. So what is a RAG? This is a kind of definition, a technique that combines retrieval-based method with AI models to produce more accurate, relevant, and informed response. So this is the a key thing: more accurate, relevant, and informed responses. And it is widely used in tasks where large knowledge bases, document, or other external data processing work, such as question answering, summarization, and content generation. So this thing will be more cleared out when you go into the architecture, where I'll explain how you use a document and an LLM together in a system to get outputs tailored to you from the document. Right. So the major problems that RAG actually solves is inefficiency of end-to-end retrieval system. So retrieval system is not something that we are seeing today after the popularization of this LLMs. Retrieval systems are traditional; they are very old, right? So traditional retrieval-based systems return raw documents. Okay, so what happened is when you pass a document, any document, to a retrieval system, information retrieval system, what they used to do is they would just return some parts of this document directly to the user. Okay, now the thing is that if I am reading a research paper, right, and I am not able to understand something from the research paper, some methodology that they have followed, I am not able to understand them, right? So if the retrieval system retrieves something and gives it to me in the words that are already in the paper, then the only thing it's doing is saving my time, that I don't need to run through pages of the document and search for that part. That's the only thing. But the complexity of the words in the document that I'm passing, the research paper, is still the same. So the information retrieval systems only retrieved information, but kind of, I'll say, failed to explain it to the user, right? So that was the thing. Raw documents or text snippet, but don't generate natural language explanation or summaries. So because a language model is involved inside the system, the language model, if I kind of go here, now this language model, this LLM, can rephrase it and present it to me depending on the prompt provided to it. So it can, if it's told to like rephrase it to like explaining it to a 5-year old or 10-year old, it can do that. It can break down complex topics into simpler topics, right? And that's where this RAG shines. Okay, so it not only retrieves information from the document you give it, it also explains it to you. Right. Again, another thing, flexibility in domain adaptation. So in a RAG application, today you can give a finance paper. Finance paper means finance report of a company. You can give it another any type of document. Your CV, it can analyze your CV. You can give it a research paper, any law paper, anything that you want. Basically, you can give it to a RAG system. There are RAG systems that are very much specific to domain, but again, for starting out, let's not go into that constraint right now. Okay, so fine-tuning LLMs to incorporate domain-specific knowledge expensive, as discussed, time-consuming, often infeasible when the knowledge changes frequently. Okay, so we discussed this like in the previous slide as well. Okay. So RAG addresses critical issues in scalability, factuality, flexibility, and efficiency by integrating best of the both worlds, retrieval and generation. Like the information retrieval system kind of retrieves it, and the RAG kind of gives us a generated response out of the retrieved chunks. So that's the overall thing over here, that these are the problems that RAG actually solve. And this is the basic RAG architecture where you give your data source, okay, the PDF file or the text file that you need. Over here, it is chunked down. Okay, now there are specific regions where you chunk it down. And then embeddings are created. Again, there are regions where you are creating an embedding, and they are stored in a vector database, popularly called vector database. Right? And then they are kept in here. They are kept in here. When the user asks a query, the query's embeddings are done a similarity search, popularly cosine similarity is used, and the you know chunks are retrieved from the database that are called the ranked results because they are in rank, the first, second, third. They are popularly called as the ranked results, and then they are passed to the LLM that analyzes all the results, the prompt, and the query, and creates a synthetic answer out of it, and the user is presented with that answer, right? So this is the very basic RAG system that had its problem. It will discuss that in advanced RAG moving ahead. Okay, but before that, knowing how this RAG thing is really important, right? So for the data chunked down, each chunk is created an embedding out of it. They are stored in the database. When the user queries something, the similar results are retrieved and is passed to the LLM, and then the user gets the output from the LLM, right? So this is the complete RAG architecture. Now we'll do a simple code where you can understand RAG pretty well. That is what I think. So here in the link that was shared to you, you have this file, right, called basic RAG first. So we'll open this file, and I'll try not to run all these files, and that's the reason I have all the outputs saved, because it's again time consuming and we have a limited time. So we'll go and open this in Collab. So you guys can also do this with me over here. You just need to run this first to install three of these here. This is LangChain and LangChain community and PyPDF2. So it will take some time for you, and hence I have done this. So the main thing that we are going to use is LangChain as the framework. So people familiar with machine learning, LangChain is the scikit-learn for generative AI, right? So LangChain provides a lot of things that help you create a generative AI application. Uh, and what are the things that LangChain provides, especially for RAG? We're just sticking with RAG right now. Okay, there are different type of loaders. Okay, so for every type of document uh, that you can use, there are types of loaders. Almost every type of document. So if you have a CSV file, you can use a CSV loader. I'll just zoom in a bit so that it's easier for you guys. Okay, my screen is clear, right? You can see what's written over here, right? Hello.
Yes,
Yes, it is visible.
Okay. So in between, we'll have like 10 minutes of gap where you can ask your questions, your queries, if you have any. So that's how the flow is. You'll take three gaps in between because we're trying to dive deep into whatever is there. Okay. So this CSV loader, it loads a CSV file. Okay, this the data dot loader dot load. This loads a CSV file. Now, people again familiar with machine learning know that pandas is a really a good and one of our go-to libraries that load CSV files. So you can see this CSV file looks like this. So this is a pandas dot data frame. So this is the data frame that it is called in pandas, right? And when you go, if I print this data, you'll see that it does not look remotely like a tabular structure. So I have to run this. So give me some time, I'll tell you something more. So what happens is mainly LangChain works with documents. Documents doesn't mean this PDF and everything. So it has a structure called document kind of structure. Okay, so this document, if I try to show it to you somewhere, you'll see that. Okay, so this is the document that it uses. So uh, So this is the PDF loader, okay, PyPDF loader. It's kind of the OpenCV for PDFs. So when you load using a document loader, okay, so a document loader from PyPDF, so it's integrated into LangChain as well. So once you load this, it's loader, load and split. You can also use loader.load. So it will just split it if it's split, and if it's just load, it will just load it as it is. Okay. So when a document is loaded, especially let's talk about PDF right now since that is being loaded over there. We can also use PyPDF too uh, without the help of LangChain to load the PDF. So if you see, you can extract the text over here. So you can do a lot of stuff over there with PyPDF. So there are these text, right? So this is the text that you need. So you can pass this text as the knowledge base that we saw in here as the data or the knowledge base, whatever you call it, to the RAG system over at your computer. You can just pass it as it is, and it will work fine. That doesn't have any problem. But the difference you see with LangChain is it's kind of a document, okay, which has this metadata. And this metadata has some information about this PDF file. The first is the source, okay, the entire path kind of thing to the PDF, followed by the page number over here. Okay, so which page are you browsing? So when you load using PyPDF loader, you get this metadata information. And this document that LangChain has is kind of more structured than a normal text file. And this immensely helps uh, when you are creating applications. So if you use, Gemini, so I'll just ask a question over here. What is LangChain, right? So Gemini will give me an answer. Okay. So now if you see, it is citing some of the sources over here. If you, yeah, see over here, it is citing some of the sources. Okay. So this kind of thing, you can do from here. So this is the source. Okay. I'll just show you. It also has a web-based loader. I'll show you that in a bit. So I think the installation is done. Yes. Now I need to get this as well over here. So this will be content. So just first it over here. And just drag and drop it. And, and this will be slash content. Now it will load the data over here. So if you see this, it again has a ton of metadata stuff. Okay, so this is the source again. And you have the row information over here, which row is it, and in the page content you find the actual content. Okay, so home, this is one. So if you correlate with this, home, this is one. Then it will be square foot 2192. Then this is square foot 2192. Lot size 16.4. Lot size 16.4. Bath prices, everything is here. So sorry, this is how this data is represented when you use this CSV loader, right? So this kind of format is very much likable by LangChain. So when you use LangChain, you will constantly deal with this kind of formats. So this is one thing that you need to be aware of, that in LangChain you don't load data in this format generally, right? Because that's how they work well with LangChain and generative AI while you use LangChain, right? So again, there is this directory loader. It loads all the documents in a directory with the use of glob, right? So it will get all the documents that I have in the folder path. So it was the demo folder. I created a demo folder, and it had two types of docs file. Okay, so you can see the metadata, the source again. It is called report trw. This is the page content. Okay, so this is the entire string of data that is there in the page content. Right, then again there will be, because there are two documents as I told, there will be another page content over here. So this is big, and the last one is very small, right? So this is another page content. This is another document, right, where the source is this the same file, but it's called speech.docs. Okay, so this is the page content. So you can load multiple documents together, multiple PDF file together, multiple uh, text files together. So it's really easy using this directory loader, because it again formats it into a document type. This PDF loader we already discussed about, so how it is different from this PyPDF2 native PDF reader. And again, this is a web-based loader. Okay, this loads the text from the website. So this is the website we have over here. Okay, now if you saw, you can literally like give this website source when you create something like this, right? So you can just give the source a clickable link so that people can visit where your source was, and it will also extract the title from the HTML over there. So this is the title. Again, helpful if you want to create the H1 tags, what are the headings and all. You can just create and beautifully display in a formatted way, and the language is also mentioned here. So, and again, the page content has all this content. You of course need to format all the slash and everything, but you get the idea. Okay, so apart from all of this, when there are scenarios when you don't need all this metadata and all, what we can do is, obviously we can use our own custom loaders. For example, like I did use PyPDF, which is not from LangChain again, this is from PyPDF2. I can also create my custom loader over here using like request and beautiful soup. I can pass it this, and I can get all the documents and everything. Then I can format and I can show it to you. Now, if I want, if I want, okay, that this is my text, I want to convert it to a LangChain document. So I can do that. Obviously, here I can add whatever metadata I want to. I can add metadata over here. So all these things, like you get the suggestion, like the source URL and everything, I can add over here as key value there. So I can, in the document, I have the flexibility to add or remove metadata as well. So that's also a thing in LangChain specifically. Now coming to the next part. So what happened right now is, now we know how to load the data. Now let's come to this chunking part. Okay, sorry. Okay, so there are chunking strategies, and chunking is really important. The size of the chunk really matters a lot, right? When we create RAG application, And there's a source I would like to cite. It's a very well written source that I got while hindering around on the internet. So Andrew Ng told, chunking is to RAG what memory is to human intelligence. Get it wrong and everything falls apart. Right? So it's really important that you chunk it really well. Okay. A poorly chunked RAG system can miss up to 60% of relevant information. Right. Optimal chunking can reduce hallucinations by 42% and processing time can vary by 300% based on the chunking strategy used. Right. So chunking sits on the base of the RAG as prompts sit on the base of LLM. So there are a number of ways to chunk. Of course, the time will not allow me to go through everything, but I can cite you the sources that you can go through and learn. So there are some types of chunking. You can read it from here as well. All the advantage, disadvantages, everything I have written over here. I'll also source a good site for you where you can go and read all of this. Okay. So there are some best practices over here. So let's talk about three different types of chunk. Okay. The one is character text splitter. Okay. And these is of two types. Okay. One is the normal character text splitter. One is the recursive character text splitter. Okay. So this is a character text splitter. So I'll just rename it to C underscore splitter and this I'll rename it to R underscore splitter. Okay, so these two are one of the most popular chunking strategy. Not these two, I say. I'll tell. Recursive character text splitter is very much used today when we don't have much idea of the document that's coming. Okay, so it chunks on the basis of characters. So let's go to character text splitter first. So what this does is it splits based on the chunk size and the separator that it has. Okay, so I'll run this over here. And if you see this, this is a string. Okay, A, B, C, D, 1, 2, 3, Satyajeet, and all of this. So this is a string that I'm trying to show. It's around 50. Now, if I split it, it will divide it into two parts. Okay. So the thing is that it should divide it into two parts, but why is it not dividing is uh, there is this separator that comes into picture. Okay. So this separator is the next paragraph by default. Okay, in character text filter. The separator is not present in recursive text filter. I mean, by default it's none. Okay, so there is a length function everything, but we'll stick with this separator thing over here. Separator is this. Again, the main point over here is it will split according to this separator, right? So if I am doing this over here, so it's giving an and I add some new lines over here around this. Now it will start splitting from the new line. Okay, so this is how text splitter basically works. It splits based on the new lines. It does not care. It doesn't care if there is some break in the statement or something. And that thing can be handled by recursive character text splitter, where it types of cares about the content of the this text that you are having, because the reason I'm saying it is because it will recursively go and start splitting your characters. Okay, this will recursively go and start splitting your characters. And that only thing is different between this recursive text character splitter and this one. It can only have one separator, and it can have multiple separators. Okay, it can have multiple separators. So the separators are all of these. Uh, it's not there. So these are the major separators that we have over here. Okay, so that will start splitting on this basis. Okay, So first, how it works is it will check for this, and then it will get, and it will kind of check for the chunk size that we have. Okay, so then it will split it accordingly. Because it is 36, it will not do, because the length of this total is only 32, right? So the length of the chunk is exceeding that length. Okay, so this is the thing that it works in this way. It will recursively go through here, then it will go to here, it will leave empty spaces, like it will capture empty spaces that will have the character level of chunking. Okay, and this is customizable, because if I tell it to around go and split for x and y, it will do that. Okay, so x and y, now it will not take into account this slash and everything. So the main thing over here, the difference it makes is using this separator, a single separator, and it will recursively use multiple separators that are given, provided over here, and then it can split accordingly. So this is the thing. So this was just an example over here. So I can delete this. No more needed. Okay. Okay, so these are the two types of text splitters. Now there are some 3 to 4 type of other splitters that are coming into picture. One of them is Markdown header text splitter. This takes into consideration the the markdown over here, the what you call it, kind of the syntax of the document that you have. So, for example, this is the title. This is the chapter one, and chapter one has this string. This is section, and this section has this string. This chapter two, and this chapter two has this string. Okay, so this document has a structure, and this markdown header text splitter is a structure aware text splitter that splits this with the structure that it has. Okay, so you can apply all these headers to split on. So you can give this, this is the first header one, this is the header two, and this is the header three over here. So again, you give it the header and you give it the text. What it will do is it will split. So first of all, you get the header one, that is the title. This is in the metadata. So it will keep all this information of this thing, of the headers in the metadata, and the page content will be the actual string that are splitted. So title and chapter one contains this. Okay. So title and chapter one contains this. Okay. Then title and chapter 1 and header 3. Okay, title, chapter 1, and this third header, the section, okay, contains this. So it keeps the structure intact. It kind of splits according to the structure. And this is very much necessary when you go with markdown files. So there is something called HTML text splitter as well, PDF text splitter as well. So number of types where these all are very structure aware. So they don't work in this kind of basis where these work on the character basis. These two text splitters work on the character basis, but this one works on the structure basis. So what you can do is you can first use Markdown text splitter to get all this knowledge about all these headers and everything, preserve all this knowledge, and then on the page content you can use, let's say, recursive text splitter to split them further down if needed. So that's how you can use all of this. Or if the text is small in this case, then you don't need to chunk it down further, uh, because it can easily get into the context length and it's small, right? So the searching will also be faster. So in this kind of scenario, you don't need to particularly use this character level text editor, right? So this is how this structure aware text editors work. So for this, you can get a really good overview. I think it's here. Yeah. Okay, so this is by Anushka. Everything you need to know about chunking for ads. So you need to kind of go and study this if you like. And all of these that I cited over there are from here. And he has beautifully explained what all different types are there, like fixed size chunking, right? And the recursive chunking we discussed about. There are document specific chunking. Okay, the markdown we saw, so the structure await that I'm talking about. So there are different types of chunking strategies that you can follow depending on the type of document and the problem you're solving, right? So this is one reference that I'll attach over there. So with this, we come to the end of the first notebook over here. And if I want to show you one more thing, I'll just go back to my GitHub and I'll open my repos to start simple rag over here. So this is a normal workflow of a rag system, right? That you will be familiar with when you work along with this one. Okay, so you need to install all of this before putting together. And here I am using the custom loader that I have from the same language model, Wikipedia using Beautiful Soup, and this request. And again, I am using this text loader, and I'm loading this text. The main thing I'm using this is again because of the format of the document that LangChain provides, although that is not something we are going to use over here. So this is, I suppose, the first some characters that I want to see if the document is kind of loaded or not. And this is the total length of the Wikipedia page that we have. Okay, so what we did right now is we got the data. The next one is the chunking. Okay, so I'll come back to this. I'll come back to this. Okay. Uh, okay. Now don't concentrate on here. See this thing first. Okay. So this is recursive text character splitter. The chunk size is 500. The chunk overlap is 60. So this overlap is used to maintain, the flow of the conversation. So for example, there is some breakage because it can do character chunking as well, right? So first it will do the paragraph chunking, double slash n, then it will go to the single slash n, that will go to spaces, then it will go to character, character level of chunking. So for that reason, all of the chunk size will never be or will mostly never be equal to 500. They can be more or less up and down a little bit. And then what happens is, for example, there is some sentence at the end of this chunk. Okay, and it I want the flow, to be carried to the next chunk as well, so that it's easier for understanding. So from here, if there's a break, it will be a very abrupt break. So what I'm doing is 60 characters of chunk overlap. So the last 60 characters from chunk one will be the starting 60 characters of the next chunk. So that's the reason I'm using this chunk overlap to maintain the flow of the uh, text over there from one chunk to another. So this is where the chunk overlaps comes in. And then using the split documents, I'm giving it the docs that I loaded over here. Okay. So if you don't have this document, okay, if I'm loading this text file normally in Python, that will be a string, right? So in that case, you can do split text. So that's the method over here. This is split documents for docs. And then the text is being splitted right now. And so there are this 500 chunk size. So just calculate if this is the length and there are 500 chunks. So how many chunks will be there? right? So around 500 everything is. So there are multiple chunks, so multiple small documents are there right now. So we have three small chunks here. There are multiple chunks, right? Then the thing is to create embeddings. So for embedding, we have a ton of different models. Okay, so one of the most popular models that I was using that was free was Google's embedding. So specifically embedding 001. I don't know why it was not working right now, and that's why I have to go back and use from Hugging Face. So this is Hugging Face BG embedding. These are a ton of different embeddings like base, small, medium, and everything. They are created by Beijing Academy of AI. So all of these kind of provide encoding. They'll encode your data into all these vector formats. Okay, so you need to create embeddings, and that's the reason we are using this specific model that would generate embeddings. Okay, so the device that we can use is CUDA if you have GPU like the T5 DPU for the free one, or you can just replace it with CPU if you are not using GPU, or else it will throw error if you're not using GPU. Okay, if you don't replace it here. Then I am kind of normalizing the embedding. So this kind of it is used to faster simulative search. And I'm just passing all of this into the Seismic Face BG embeddings, and the embeddings is ready. Right. So now what I have to do is I have to create all these embeddings. I have to create a database using all these embeddings. So as of now, this thing is inside this variable, but uh, using this object, we have to we have to process all the chunks and create embeddings, right? So that will be done, and this FIS, Facebook AI Simulated Search, dot from documents. So all these docs have been passed, and this embedding object is being passed over here. So FIS will create a vector kind of database, in memory database, using these embeddings and done. So now what we have done is we have created the embeddings and also the vector database. This is the in-memory data store kind of thing that is given by Facebook using Facebook AI Simulator. So there are a ton of other options we can go to, like Chroma DB is there, Pinecone is there for using cloud-based data. But now it's just an in-memory store because I have been working with Five for quite a long time now, and Five is really good and in indexing and everything, and it does not cause major problem. But yes, if I'm building some production grade applications, I would prefer going with some cloud providers, right? Then I would need to move ahead. Okay, so all these things are created. This is loading. So this is where all the things are kind of coming as one part. Okay, so now there's something called the system prompt. Okay, so this system prompt kind of you know, the system prompt kind of guides the entire LLM model. Okay, so this is how this set the role, this sets the tone of how the model should speak and everything. So that is the system prompt. Okay, for the model. So the system prompt tells answer the following question based on the provided context only. Think step by step before providing a detailed answer. If the answer is not present, simply say I don't know the answer and nothing more. So, and again, I'm passing this context over here, the context over here that will be retrieved, from the vector database that we created. So, using chat prompt template, we created a system message, and the human message is just the query. Sorry, is just the query that the human asks. Okay, and there is a AI message that the model gives a reply. Okay, so question is here, and then I'm creating a stuff document chain, and I'm passing the LLM the prompt, and the LLM is created over here. It's a Llama 3 8 billion model, and I used Grok for it. Grok is providing like really good LPU that is free to certain extent, like crops down the token length to 8K, even if the token length is 128 or something. Okay, it will always crop it down to 8,000. So the token length context window is really small when you use crop. You have to pay them to get better. So because this is a big model and you can't run it, you need cloud provider to help us out. So that's where Grok comes in. There are other providers as well, like Together is there, but they are very limited to use. So Grok is something that I use. So I'm getting the LLM, the prompt that I created using this tag prompt template. Then I'm creating a retriever object out of the database, and there's a retrieval chain. Okay, so what are these chains? Chains are actually kind of used to combine multiple things like prompts, LLM, some tools. So one after another, they are used to combine all these things. So this is a retrieval chain. We'll take in the retriever that we created over here and this document chain. And then in this retrieval chain, we'll invoke this with the input that is our question. And whatever the question will be, that will be uh, kind of converted into embeddings, and then the vector search will happen and it will come out, and the I mean the relevant chunks will come, and then using the LLM the final answer will be given to us. So the final answer is in response. So response has this answer, and using answer we are just getting the output from response of answer, and we are replacing some kind of formatting over there. If there is any star mark, it will be replaced by slash n and all this to like impose next line. So the question was, what is this web page about? And the answer that I got is from the web page appears to be about large language models, a type of artificial neural network. Now, without LLM, this would not have worked really fine. It would only have given me some matching documents. And due to this LLM, I'm getting this rephrased answer. So this is how a simple RAG works, right? So that is the thing. Hello, IUC.
Yeah, hi Satya.
Yeah, can you take a small doubt session now?
Yeah, please do, please do. I think we'll just pause here for 10 minutes. If anybody has any questions,
Yeah,
please feel free to unmute and ask Satyajit about it.
Hey, hi Satyajit. This is Panduran.
yeah. Hi,
I
Pandurang. How
have
are
a
you?
question with regards to if we have to feed the data from database. So you will have, let's take an use case, a simple use case wherein you have an e-commerce portal and you have customers' data, and you want to build a chatbot to give the information about the customer's current context, like if there is any order placed. So I'm just creating a sample so that to make it simple. So if I have to feed this data which is available in database, how this can be uh, facilitated?
So you can get the data using SQL first of all. Okay, so you can get the data if you are using Python. You can go with SQL Alchemy. You can get the data from your database if it's like Postgres and all. So you can get the data from there and use CSV loaders and build a drag on top of it. So that was the thing that CSV loader can facilitate.
Okay, so there, if that has to be feed, like it would keep on changing. So I have to keep on feeding the data.
Right, right, right.
So as and when there's a new record that is being added, inserted, or new orders are being placed, I have to keep on updating the
Yeah,
embeddings or the.
that will automatically be done, right?
Okay.
So if you can run a cron job,
Hmm.
okay, so in n time period, it can automatically go fetch the data, run the file, and it will get automatically done.
Okay, so the next question probably would be like you mentioned in your particular diagram wherein embeddings are. So whenever there is a question is being made, there would be nearby or the records would be retrieved and it will be feed back to the LLM. Is it that way? Like the answer is been formulated by the LLM uh, engine?
Yeah, the answer is being formulated by the LLM engine because LLM can only generate text. That's the thing that LLM can do. LLM cannot do any other thing. What we have to do is we have to write the code and give that to the LLM. Right. So LLM can only generate text.
Okay, fair enough.
Yeah, welcome. So any other questions?
So, like what happens over a period of time, the same data, it gets new values. So let's assume price was updated. So then how you direct it to use the latest, and how can we do that?
So that the LLM cannot do anything. So
Mm-hmm.
you have to change the data. Like so, if you know, for example, in let's say the 7 days, uh, sorry, the price is being upgraded in every 7 days, right?
Right.
So if you know the frequency,
Mm-hmm.
that is the thing that I told to Pandurang, that if you know the frequency, you can easily run a loop that will go fetch again, or kind of a cron job, right? That will go fetch again and remove the old data, place it with the new data, and the LLM can regularly query the data after that.
Okay, so that means I have to create embedding from the ground every time.
Right. So
Is
if your
it
data is stagnant, then you can create an embedding
okay?
for once, and then you can go on retrieving it. If the data is new,
Mm-hmm.
you supposedly have to create new embeddings because embeddings are just a representation of your data itself.
Right.
So
Right.
that's how.
So I was thinking, is it possible to use metadata where we specify the date and use it? Is that
Yeah,
possible?
yeah, you can use the metadata. That's the thing. No, that's the thing that Langchain beautifully does, right?
Mm-hmm.
So there are some RAG techniques that I'll not discuss here,
Okay.
uh, but there are some RAG techniques due to the time limitation. Like 1 hour is already over, right? Due to the
Yeah.
time limitation that we have, because there are like more 3 to 4 techniques that I'm going to discuss right now after this Q&A. So you can use the metadata and fetch relevant types.
Okay. Okay. Great. Thanks.
Yeah, welcome.
सोनल क्या ये संतरे की चिट्ठी है तो
Any more?
में निकले जो उसने रखे हुए थे जमीन पे
Okay. So IUC, I think that we should continue with the discussion.
Sounds good. Yeah.
Yeah. So now that all of us are like kind of familiar with, this architecture of RAG. Okay. So after this, there's one thing over here that I would like to talk about is why does this chunk size matter? Okay, this thing will come up in the next session that we are going ahead. Why does the chunk size matter? Okay, there are 2 to 3 main things. The
Hello.
first is there is a fixed maximum token limit of every LLM. Okay, so like I told you that the context window is kind of crunched to 8,000 only by Grok. So at a time, I can only give it 8,000 tokens, and tokens are not equal to characters and words. Okay, so every LLM treats token differently. So if you have an LLM and you need to know uh, what kind of how many tokens are you passing, if you have a text string, okay, of 10 words, that every LLM will create tokens of different sizes from there. It's not like it's if it's 10 words, then you have only 10 tokens right there. Okay, so every LLM interprets in its own way. Uh, so what happens is you can get that LLM, and there is a function get num tokens. You can pass the text, then you will get the number of tokens out of that. So one kind of splitting technique is also there that focuses on tokens only and helps us to split using tokens. So that kind of things are also there. Uh, so you need to be very much careful about the token limit. or else you'll get an error, right? If the chunks are larger than the limit, either it will be truncated, which actually loss of information, right? When machine learning also, we faced a lot of problem, loss of information when there was, imbalanced data. So it was always advised for us not to remove data or to use smart and other upsampling techniques over there. So data is the core thing that we have, like we had in this discussion, right? This data is coming. So we don't want to remove any data. So preserve as much as data is possible, right? So we need to be very much mindful of our token limit. So this is the thing, and there is a kind of a trade-off here. There is trade-off that small chunks lose the context, right? Because the relationship between adjacent chunks might not be preserved. Again, this small chunk and this small chunk. Okay, so there is a chance that the context has been lost over here because they're very very small, very very small. Okay, but again, on the other hand, larger chunk which retain more context, but there is a risk of exceeding token limits. Okay, so we have to find a sweet spot between uh, not having a very small token and not having a very large token. So there is always this trade-off present over here. So again, chunking also impacts how data is indexed for semantic search. Okay, smaller focused chunks result in more accurate embeddings for
Your
retrieval. This
screen
is,
is not shared.
oh, I'm sorry. Okay, so do you see my screen now?
Yes.
Yeah. So these are the kind of nodes that I was talking about over here. So the smaller focus chunks result in more accurate embedding for retrieval. So this is really important. There's a thing called parent document retrieval that we'll see in some time. So this will be really important in there. And there is one more very fundamental thing over here, that every embedding model has a limit on the number of tokens that it can embed at a time. Okay, it can process in a single pass. The size of a chunk should not exceed this limit to ensure that the embedding model processes the text correctly and generates meaningful embedding. So these are some really important things to keep in mind when you are generating the chunk sizes, right? And this right here was one of the core reasons. Okay, why I told you that even after this structure aware chunking that you do for PDFs, for markdown files, you should, if needed, do more character level chunking so that the chunks can be finer if needed, right? So there is this thing called hybrid search. Now we're getting into advanced RAG. Okay, so we saw the normal RAG architecture. You can normally chunk it, embed it, store in a vector store, do the similarity search from the user's query, give the rating. But it had some fundamental problem. It will be getting clearer once we move ahead. Okay, so what happens when we do a similarity search between two sentences? Okay, so the similarity search finds out the similar results. Okay, this will find out the similar result, but not the exact match. But not the exact match. But in scenarios where, for example, there is this medical thing that I'm doing. Okay, so I have this data set, let's say, .csv or anything. Okay, so here is the medicine's code. Okay, and here is the medicine's content. So what all chemicals this medicine is containing. Now, it's always better if a person is asking that I need a medicine that has some chemical, let's say potassium in it, for example. So if I do a similarity search, because potassium is a chemical, I'll get the names of other chemicals as well. But if I want to do a hard match, like the proper hard match means the proper keyword match, then it will not give me that fine result, that pinpoint result that I need. Because we are using semantic uh, to kind of search all of this. Okay, so that's the reason I'll not get the proper fine result that I need. In that place, hybrid search is something that comes important. Okay, so what hybrid search does is it uses two types. Okay, I mean both of the types. One is the uh, similarity retrieval, that does the similarity search, and the other one is keyword retrieval. So now it can match. Now this RAG system, can match exactly the keywords. If I'm searching for potassium, then the first document that I get back is of potassium. Okay, we'll see that in action. Okay, so this is the thing. And there is an ensemble retriever, and we kind of combine these results with a ratio. Okay, because there are two types of results that are coming out, so we have an option to take. Okay, so take 50% of this, kind of weightage. Give 50% weightage to this, give 50% weightage. But if it's a like medical database, like I told you, then it's really important for us to give this keyword search more value. If we desire to, if you know that what you are doing and you desire to, then you can give it like weight of 0.75. And this similarity search, which uses semantics, we give 0.25 the weightage. Okay, so all this keyword search will override the semantic search, but semantic search will also come into the picture, right? So depends on the use case. So this is an example that the query vectors are there. A similar representation is coming. This is not the exact SU that the person is asking for, but here the exact match is happening. Okay, so this is the exact SU that is coming. So this is called hybrid search that I explained. So this is a combination of having a keyword style search and a vector style search. Okay. In users query, we look for keywords and then we do a keyword based search with all the chunks that are available. It uses both a sparse matrix and a dense matrix. So the thing that we'll use for keyword search is sparse matrix because it has a lot of zeros, and this one, that vectors that we are creating, are always a dense matrix. Okay, of like huge dimensions. For keyword based lookup and semantic lookup respectively. So why do we need this? Because I discussed, if the synonyms are there or some terms are used, vector search alone can sometimes retrieve less relevant results for niche terms or noisy embeddings. Okay, like the niche terms like the chemical names, or if you are processing legal documents, some legal terms, exact match, the keyword match over there, right? So excels in retrieving exact matches. This uses semantic understanding to find contextually or conceptually similar information. Okay, works well with structured text and metadata, ensuring retrieval from index fields like title tags or document metadata. So because in metadata, we prefer like keyword based matching because it's proper, like keys and value type of, like you saw the URL. So if I need a proper defined URL, I'll obviously go for keywords based matching. I'll not go for this other type of matching, which is called the vector search, because vector search give me the similar result. I want the exact URL over there. So in that cases, I can easily go for keyword based matching. Okay. But again, if I only go for keyword based matching, I lack, the semantic meaning, the other things that I need. So in there, vector search is also there. So vector search handles unstructured incomplete text by using semantic embedding to infer meaning and locate relevant passages. Okay. Results can be sorted to prioritize exact match while also including semantically related results. So both of them are useful in their own way. So when should you use them? Like medical documents, legal documents, product discovery. Like if we have some product, we need the exact keyword match for the product code or the exact product name. Okay. But again, vector search will help with vague or descriptive queries. For example, this comfortable chair, $100 to $100. Like if you go and search on Amazon for this, then it will give me a ton of results. Okay. But again, if we have some product code and if we have the like feasibility search by product code, the first product will be the exact product we'll be looking for, and that will be the keyword search. So this kind of help you can get over there. So what is the disadvantage? Mainly when the data is very small or homogeneous, this hybrid RAG cannot be used. I mean, it can be used, but it should not be used. Okay. If there are very similar content, okay, as any one of them can alone do the job, so it's not needed to get the hybrid thingy over there. And real time streaming data, because it's the data is very much changing at high speeds, it cannot be used very easily over there. It's not optimized for that kind of scenario. But when the user query is poor, okay, then nobody can help. If I'm just going somewhere asking some random question, then obviously no similarity matching can get me good results, right? So, due to overgeneralization of vector search, it can give me irrelevant results. So that's the thing with hybrid search. And let's see some details about hybrid search. Oh, sorry. So there are two things that are used for keyword-based searching. One is the TF-IDF, another is the BM25. We'll come to both of them. So I'm not using any LLMs here. Just I want to show sorry how these things work. Okay. So there are some document, let's say. So this is your entire document I'm assuming. First line, second, third, and fourth line. And this is the query that the user wants to ask. Okay. So I'm initializing a TF-ID of vectorizer, and then I'm fitting on the documents over here. Then when I'm using the two array, and there will be all of them, right? So I'm just seeing the first one because it will be unnecessarily long. You can see a lot of zeros over here. Okay. So all of things are here. Then again, why that I have this query uh, that I'm transforming into y, and this is the thing that we have. So a lot of zeros. So this is parse. And I'm doing the cosine similarity between x and y, and then I'm sorting and I'm getting all the documents over here for you. So the first one, the exact keyword match, because it's Satyajit, the first one should be this one. Okay, so we're getting the exact keyword match over here. Okay, so this is how exact keyword match works. Uh, if I would have written rag over there, apart from Satyajit, then either this or this would have come at the top. Like you can do all this experimentation, you have all the codes over here so that you can get a clear understanding. But generally, most of the time you'll see we are using BM25 and not TF-IDF mostly. So BM25 is kind of an updated version of this TF-IDF. It had some problems, and I'm listing two, three down here. Okay, the first thing is that handling the document length. So TF-IDF has a very simple formula. Okay, TF-IDF had a very simple formula. So it is the term frequency into log inverse of the document frequency. Okay, so this is a very simple formula that TF-IDF works on. And what is TF? Number of occurrences of term T, any term in the entire document, D, divided by the total number of terms in the document. So this is a term frequency, and this is the inverse of the document frequency, which is log, uh, you know, a total number of documents in the entire corpus and number of documents with term t in them. So is the inverse of the document frequency, and they are multiplied, right? So this is a very simple formula that it works on. Okay, and what happens is it doesn't account for the document length. So what I mean to say is a long document with repeated term get unfairly high scores even if they're less relevant. Okay, so consider two documents with the query machine learning. So the document one, machine learning is important and is widely used in the industry. And in the document two, machine learning is important, machine learning is widely used in the industry. Both convey the same meaning right here. And ideally, I would like to see document one. Okay, but again, TF-IDF would assign a much higher score to document 2 because of repeated occurrences of machine learning, even though doc 1 might be more concise and relevant. Okay, so when you need more concise and relevant answers, then TF-IDF fails over there if if the occurrence of certain terms are higher, right? So that's one of the problem. Okay, that's one of the problem. How BM25 handles them is it normalizes the term frequency based on the total document length that we have and ensuring fair treatment for shorter document sizes. The normalization is used in BM25. So this will avoid over rewarding long documents with repeated terms. Okay. So this is a basic thing that BM25 does over TF-IDF. Okay, and one is the term frequency saturation that TF-IDF faces mainly. So TF-IDF treats term frequency very linearly. Okay, so a term appearing 10 times is considered 10 times more relevant than a term appearing once. Okay, so if there is this query like artificial intelligence, this is the query by the user. There are two documents, two sentences over here. Artificial intelligence is a field of study. So this is very relevant. We can pass it to the user. The second term is artificial intelligence actually uses in every line. So it's not like telling you this is the entire sentence. Right. So here artificial intelligence is repeated for 3 times. So TF-IDF would unfairly boost document 2 due to repeated occurrence of the query terms. So high chance that I'll get this document 2 as the answer instead of document 1. Okay. So that's the thing. And obviously, you can try these above. That's the reason I have the TF-IDF score above for you. You can properly do this and you can see what's happening with TF-IDF. So what BM25 does is introduces a saturation mechanism using K1. So it is K, and beneath K there is a 1 written over there, ensuring diminishing returns for repeated term occurrences. In the above case, BM25 recognizes that after a certain frequency, additional occurrences of artificial intelligence do not significantly increase relevance, right? So it very intelligently gives you all those documents uh, when compared to TF-IDF. Okay, and the K1, it's a hyperparameter that you need to tune, and there is this B also, that's also a hyperparameter over there. You can see how the TF-IDF is changing with BM25. So BM25's full form is best matching 25. So I guess 25 is the iteration of the change that they made. So they started from 1, 2, 3, 4, 5, and 25 were the best uh, derivation of the formula. So they did this thing around
Call.
25 times to get the perfect formula. So that's
मम्मी
that's
आए
why it's
हैं.
called BM25. Okay, and that's the reason BM25 is immensely used for keyword-based search these days. So I have another file for hybrid search. So you have to like install all this rank BM25 over here, and you have to get this BM25 retriever and this ensemble retriever with it. Okay, so fires again, and I am not using this time. So these are the documents again. And this is the BM25 from text document. So a retriever is being created over here, and K is 3. So if I say Satyajeet, it is retrieving 3 documents that are matching. So very much smaller than that code over here, but performs a kind of similar for the example that we took. Okay, and then we are creating a dense retriever. I told that I immensely use this, but now I don't know why it's not working. I have to look into it. But again, I'm using this base over here. So again, this is for the dense embeddings, kind of transformer-based models over here, and I'm creating the vector store very much similar to the one that I did previously. Okay, then I'm creating a retriever out of this. In the previous notebook, it was called DB. Now I'm calling it a file vector store. Then I'm getting the relevant documents. Okay, LLM is not used here. I'm getting just a relevant document. Who is attending this session? And I'm getting everybody is attending this session. Okay, so this is not the keyword based search. Okay, this is the semantic search that I'm doing vector search over here. Now what I'm doing is ensemble retrievers. This is BM25 and this is 5. So both the weights are 0.5, 0.5. So first is using this ensemble retriever, I'm retrieving what does the session cover. So what is happening is, you see, everybody is attending the session is the first thing that I'm getting. But the answer is in the second document. Session also covers advanced rags. Okay, but the reason I'm getting this one is, I'll just decode it for you. Now I'm using 5 retriever, not the ensemble one. So I'm using the 5 retriever for the same question. You see the answer over here. Session also covers advanced rag. So for this scenario, I'm getting the correct answer in the first go itself. Okay. But when I'm using BM25 retriever, it is saying that everybody is attending the session. Okay. So while using this ensemble retriever, because both of them are contributing, so here this one is coming at the first one. So you can see this is an error. Obviously, I'm going to pass all of these 3 documents to the LLM when I do that. Okay. But again, I'm just letting you know that when to use and when not to use. I told you in this introduction over here that when you data is very small, okay, then either keyword based search or vector based search alone work. So because the data is only 4 documents, right? The data is only 4 documents. You don't need this ensemble retriever right here. But when you need it, there are specific use cases, right? So here, this is kind of a thing that is happening over here. So you have this, you can play around with it, import it from data, your own data, and play around with it. So you can have a better understanding of how the hybrid search works. My main motto was to let you know what is and show how this thing works over here. Now let's go to this uh, parent document retriever. After this, we'll take a short break. So it's a very big diagram over here. So what is happening over here is, okay, I have this original document over here. I have this original document over here. And then I'm chunking that down. Okay, like I did in the first. But again, from each chunk, I'm deriving 2 more chunks. For each chunk, you see, I'm deriving multiple chunks, like two chunks over here. And I'm embedding these chunks. And I'm not touching this one, this bigger one. Okay. I'm just embedding the C chunk over here and doing a cosine similarity with the query, and I'm getting some chunks and passing to the end. So this is called a parent document retrieval, where if the original documents are really big, okay, like the project I was about to showcase to you was based on Gita, but I don't think we have the time to do that. Was based on Gita, right? And it was really big. The Gita is very big. So in that, what happens? For example, I am doing a parent chunk of 1 page. If it has like 1000 something pages, I am doing like 500 words in 1 pages. So my, if I'm doing recursive text editor, the chunk will be 500 pages. So the first page will have some data. right? It is very much possible. It is very much possible over here that each and every page has multiple paragraphs, right? And in one paragraph, it's talking about a story, and in second paragraph, a different story is being talked about, right? And if I'm keeping this here, that means that you know this is a very crowded data. It does not have granularity in it. Okay, so if I'll search something over here, the problem that I'll face is if I'll search something over here, the problem that I'll face is because it's not granular, it has a lot of context in it, it will take time to search. Okay, the similarity search will take time. So if I'll do something like this paragraph is one smaller chunk, and this paragraph is one smaller chunk. Okay, now it is more refined. The content in it is more refined, right? So now the similarity search will also work a bit faster because the chunks are very small. But but what if this entire story, because the data is linked, I suppose. So what I'll do is to the LLM, after I let's say that if the user asks a query and it is very much related to this first paragraph chunk, right? So what I'll do is for better context, I'll pass this entire page to the LLM. Okay, this entire page to the LLM. So what will happen? The vector search will happen faster, and the LLM will also get surrounding context to generate a story and tell you. Okay, so this is the entire idea.
Hello.
When the
Hello.
smaller chunk
Hi Shreya.
doesn't have ample
Sorry
amount
Pratik.
of context for the LLM to create a
Sorry.
like text out of it,
मैं
to
सो
generate
रही
some
थी एक्चुअली,
response,
मैं सुबह
which
5 बजे
gives
सोती हूँ
a
ना,
good response
फिर
out
उठ
of it.
ही नहीं
So in
पाती
that case,
हूँ।
I'll pass this bigger chunk
अच्छा अच्छा,
over there.
मतलब मैं आगे के लिए बता
Okay,
रही हूँ, अगर
so
कभी
this is the
अर्जेंट
idea behind parent
जाके
document
आवाज दे
retrieval.
दिया करो तो
Okay, so this is the thing.
अच्छा क्या काम था?
Parent document retrieval is a RAG, is a specialized approach to retrieve where documents are hierarchically organized, so parent and child.
अच्छा अच्छा
The
अच्छा।
system focuses on retrieving a parent document or a high
तुमने
level
सुनी नहीं
context
थी?
which may contain or relate to the
सो गया
information needed to answer
ठीक है।
the query, ensuring a broader contextual overview is provided rather than
हेलो।
a fragmentary or isolated result. Right? Another thing is why do we do this? Okay, when the document are broken into smaller chunks, paragraph or sections, retrieving isolated fragments can lead to loss of context. Okay,
हेलो।
this can cause the RAG system
अभी
to
तबीयत
generate
ठीक है?
irrelevant or incorrect response. A parent document retriever fetches the larger context,
हेलो।
okay, to
क्या हो रहा है
ensure the smaller chunks
में?
are interpreted correctly.
फोन
Okay,
में।
because if the context is not enough, okay, I am dividing into small paragraphs, but if the context is not enough in
हेलो।
the child, then the model will start to hallucinate,
अच्छा,
because we
तुम्हारी
try
अभी
to fill
तबीयत
in the
ठीक है?
missing gaps, right? Generative models can hallucinate or
अजीब
misinterpret
कुछ
information
हो
when
गया?
provided with insufficient context, right? So this is the thing. It works well when dealing with massive data sets when computational efficiency matters.
बाय बाय।
So this is the thing. And when to use it? When you need understanding of the broader context before answering, especially if smaller chunks might alone lead to ambiguous or misleading responses. Right. So this is a time when isolated chunk retrieval results irrelevant or out of context fragment being retrieved, hallucinations can occur. So this is when, like I discussed in the previous slide as well, you need to retrieve the entire bigger document. When the goal is to summarize large documents or provide a high level overview before diving into the details. So because you have the entire page, now the LLM has the entire idea about topic. Now it can give a summary, it can, and if needed, because it has all the information, it can also dive deeper. Okay, so this is the thing. Mostly it is used for large document, right?
ये
It is
यहाँ
used
पे
for
क्यों
large
बैठा
document
है?
normally.
नहीं,
Disadvantage:
मतलब इसका काम हो
uh,
गया है? इसकी
retrieving
दीदी
processing
क्यों नहीं आई?
entire parent document can be more resource intensive, obviously because you are going back and fetching
नहीं नहीं,
bigger
इसकी दीदी
documents,
क्यों नहीं
right,
आई?
compared to retrieving smaller chunks. So higher memory uses slower response
रहती तो
time.
एक साथ ही है।
Okay, so sometimes what can happen,
हाँ?
because it's not very much necessary that for this small child chunk everything is there in this bigger
क्या?
chunk. sometimes, sometimes there can be uh, other things that can be noise as well, because it's a bigger chunk.
तो तुम
So maybe
दीदी
the
नहीं हो
story is
उसके?
getting over in this paragraph, and from this
तुम
paragraph there is
भैया नहीं
something
हो
else,
उसके?
right? So that is the thing. So
तुम
parent
काफी
document
ज्यादा
retrieval might overlook the precise relevance of smaller chunks
मुझे
within
लगा
the
मैं
document.
दीदी है, ये
This could
रिलेटिव है।
result in a less specific answers if the system focuses too much on the broader context. Okay.
हाँ, मुझे इसीलिए
So
लगा
large
दीदी।
parent
सॉरी।
documents may exceed the input token limit
चॉकलेट
of the
खाओगे?
language model. This is really important,
खाओगे?
because the language
चलो।
model has a token limit, as you discussed at first.
ले ली।
So if this is
कितने
really big
खाते हो तुम?
and you have time to pass
6।
it,
6
that would
खाते हो?
obviously exceed the token limit.
लव यू।
And so these are all the disadvantages.
बेबी
Now if you see the code, the
लव यू।
parent document retriever, there will see that there are two kinds of parent document retriever. Okay,
छोटू
so
क्या?
first we'll look into the first kind of retriever that we have. Okay, here I am again using that Wikipedia. So when, for example, there is one page, okay, or there are 5 to 6 pages. There are 5 to 6 pages over here, and in a combination there are approximately 5,000 tokens. Sorry, in a combination there are approximately 5k tokens. So 5k tokens will never exceed the context limit of this LLM. So now I have chunked it into smaller chunks for granularity, and when I get the chunk, I retrieve the entire document because I know that this is a very small document and it won't affect uh, my context length. Okay, so this is a parent document retriever where the entire chunk is the parent chunk, right? So again, I'm creating the embedding model over here, getting the embedding model, and retrieving full chunks rather than smaller chunk. Okay, so it's good to use if the entire documents aren't too big themselves or aren't going to return many of them. Okay, so if there is just a small one, you can do that. So creating the child splitter where the chunk size is 500, and this is a chroma db that I'm using, and the embedding function is bg embedding that I have, and this is the store in memory store, and this is the full document retriever. The parent document retriever is something that I'm importing, and this is the vector store, this is doc, and this is the child splitter. So it will be splitted and the entire document will be retrieved. Okay, so whenever I'm talking what this is web page about, it will start retrieving everything. Okay, it will just retrieve everything that's there. So it's really big because it is retrieving all of that. Okay. Now what I'm focusing on is to retrieve larger files. So this is the architecture that we saw. So I'm creating the parent splitter with the chunk size is 2000. Okay. And the child splitter with the chunk size is 4000, 400. Sorry. So creating the chroma vector store, and this is the in-memory store. After that, I'm creating this parent document retrieval vector store and the story assigned. And this is the child splitter that we are taking, and again a parent splitter is also being taken. So this one was not there, this parent splitter. Okay, because it did not need to split the parents, right? The entire document was what we need to pass. So again, into this retriever, we're adding all the documents that are there, uh, that we have over here, right? So the big chunk retriever that get relevant document, what is this web page about? Okay, so now what it will do is it will not get because this is the first one and just seeing the first page content. There is not much over here. There are some references kind of thing, a bit of progress and all. So what I'm doing is I'm properly creating this thing, you know, what you call this LLM stuff, everything. So I'm passing the big chunk retriever in the document chain to the retrieval chain, and I'm invoking it with a question. Okay, so the question, I think I wrote somewhere.
इनके भी आ रही हैं हाँ तुम्हारे तो चाहिए क्यों इनके भी काम करती हैं
Yeah, I guess this one. So this is the query that I had. Okay, what is the web page about? So now that I wrote somewhere this question. Yeah, here. So what is this web page about? Reviewing fast. And the output that I got from the LLM after the big chunk retriever is based on the provided context. I understand that the web page is about artificial neural networks, machine learning, and data mining. Okay, so it got some things from there. What is it telling? So this is how this parent document retrieval works. And we mostly don't use when we have large chunks, this entire thing where the full text is the parent. So I just showed you that this is the code for that, and mostly don't use that. But yes, when you have big documents like I had the Gita, or you have some bigger documents, then you can go for this kind of technique, and then you can create this parent splitter, split into parents and child first, and you can go for that. Hello. So
Yeah, hi Satya.
yeah, hi. So I think we should open up for questions.
Hi, Satya.
Yeah, hi.
Okay, we'll just pause for questions then.
Yeah. So anybody has any questions?
Yeah, Satya, I have a question.
Yeah.
Right, this is Raghav here.
Yeah, hi Raghav.
Right. So I'm actually working in the EV space, Satya.
Okay,
So now
nice.
actually what is happening is that there is this new concept which I want to apply to my EV space, which has come up, which is called vertical AI. You know,
Okay, yeah.
I'll just turn on my camera also. Wait. Yeah.
Thank you.
So vertical AI has come up. Hi, thank you for doing this.
Thank
Yeah.
you so much for being a participant.
Yes,
Yeah.
Satyajit. So vertical AI has come up. Now I understand that sort of you will have to sort of train your models with, let's say, EV specific data and all, right? But just wanted some feedback from you on, let's say, uh, so how to structure this training and all. Just thoda sa, if you can give some feedback on that. This is a not a very conventional sort of a request. ऐसा नहीं है कि this is not legal data or healthcare data or something. This is EV data. तो थोड़ा सा अलग है. The field is also new. Data भी कम है. ऐसा नहीं कि पुराना legacy field है, banking है,
Right,
उसमें आप लगा रहे हो and all. तो ये नई field है और नई field में आप नई technology लगा रहे हो. So
right.
just some comments on that, Satyajit. And I'll just be in touch with you, sir. I'll add you
Sure,
on.
sure. And don't call me sir, please.
Ah,
Okay. So the thing is, we should use traditional AI
ah,
where we can use that. क्योंकि the reason for that is because this LLMs running them are pretty expensive. Okay. So this is not a very cost efficient method to keep an LLM running as you can keep a traditional AI model running. And this LLM, this large language model, I'm talking about this billions of parameterized models that we use today, like Gemini, ChatGPT 4. These are kind of ultra large language models because they're very huge. Billions. You can't run this on your home system, right? Because it needs a high computational power over there. So if you have and if you can, you should train a lighter language model. Maybe go to the BART side, right? Go to the basic transformer architecture that you have and see if the results are fine, right? Because you need a lot of data. And if had it happens so that you have to train all these kinds of llama models and all, right? What you can do is you have to first get the models. Llama models are really easy to get. You can't get ChatGPT because you have to do instruction fine tuning over there. Okay, so that's a different thing. But if you can get the model, like you got the llama model, and you have the data with you, you source the data. Okay, you kind of have to after that quantize that model so it can run because it has a lot of weights and biases, a lot of parameters. So you have to kind of get them down. Okay, so when you quantize them uh, from a 16-bit to a 4-bit, from a 32-bit to a 16-bit, so now it's a smaller model. Okay, there's some loss of data obviously because you are reducing them down, but again you are topping that up with your own data that you have over there. Then you can use like fine tuning techniques like LoRa and everything to again fine tune them. But beware, even if the model is quantized, it can take a lot of space to run and a lot of computation to run. Right. So that's my point. So if you can, okay, if you can train a traditional machine learning model, language model, because it's very resource intensive and it needs expertise to even create data for this and to run a model as well. Right. It takes a lot of computation expertise for that.
Thank you, sir. I'll be in touch with you on LinkedIn, sir.
Yeah, sure, sir. So anybody else has any questions? Okay, so IUC, I think nobody has the questions. So thank you so much, sir, for asking me. And I think we should continue this session because the time also we have is very limited right now. Hello.
Yeah, yeah, Satya. I think we should continue.
Hello, hi Satya. So I will be
Yeah.
like wrapping up the session.
Okay.
Uh, I hope I am visible.
Yes, you are.
Yeah, so I just wanted to take a moment to like thank you for such an amazing session, and we have learned so much today. Now I just wanted to like say that you all have taken out your precious time for the participation in today's session. So if you all want to like stay in touch, and if you want to like continue joining our other sessions, feel free to do that. And it was such a nice time that you all have taken out. Thank you.
Thank you so much, everybody.
Thank
One
you.
second, Satya. I think the last leg of your session is still left, right?
Yeah, a bit of that is left.
I think you should continue and finish because we still
Okay.
have time. You take your time and finish. Simran, let's just give him another 20,
Sure,
30 minutes so that he's able to wrap up his session.
sure.
Yeah. Thank you so much. Yes, I'll just share my screen. Okay. So moving ahead with RAG fusion, this is another interesting architecture that we have. So what happens is there is a very big problem when you give a chat interface to people. Okay, so what people do is they kind of go because many people they don't understand how things work, right? So they will go and ask very vague questions. For example, when I had that Gita running, there were people coming and they were asking, I am in depression because most people have heard that Gita has solution to all your problems, right? So in such cases where the query is very vague, you can't do a really good semantic search. If I'm writing just I'm in depression, okay, I'm heartbroken, so very efficient search would not be there. If I write a better question, okay, I am feeling sad, okay, I'm not able to do xyz things, what does Sri Krishna suggest when Arjuna was feeling down? Now, because it has the context, it has words like Sri Krishna, Arjuna, right? Then it can do a better, search over there, and the search can yield better results. But obviously, we can't control people. What we can control is our system, right? So there is this user's query that the user asks. What we do in the backend is we generate similar queries. Like there, here is the example of like four queries that are generated. But again, let's take two, three, four, five, n number of queries that you can generate. Then there is this thing called reciprocal rank fusion that happens from all those things, and to get the re-ranked results, and then we generate the output. Okay, so what is this? This thing, I think everybody till here it's very much understandable that similar queries are generated. Okay, so what happens is, for example, the person is writing that I am in depression. Okay, now I will tell my LLM, one LLM, Okay, uh, the context is about the Gita. Create four new queries. Create four new queries from the original query that the user has given in context with the Gita. Now, because this LLM knows about Gita, what the Gita is, who the Sri Krishna is. Okay, so it has all those knowledge, right? So it will again generate query very much related to the Gita. Now, because I can have all these queries, I can do a simulative search and I can get better results from there. Okay, so instead of just a single query, I'm using multiple queries and multiple queries that too very efficient, very related to the context, right? So I'm getting a big corpus back, not corpus, I mean a number of documents back. Okay, I'm getting a lot of documents back over here. So the problem over that is because I have a lot of documents now. If I pass all of them, if I pass all of them to the user, just give me a minute.
Hello, Satyajit.
Hello.
Yeah, your mic is off.
Yeah, I understand.
Sim- Simran, just once again, I think you got a phone call.
Yeah, it's fine. It's fine now. Yeah. Okay. So uh, the thing is that now because there are multiple queries, okay, we are getting multiple documents. Let's say we are getting four documents for each query. Okay, so now we have a total of 16 queries if I only take this four. Okay, so a total of 16, total of 16 documents that I retrieved, and that will be a big one, right? That will be a big one. So what we have to do is we have to follow a process called re-ranking. Okay, so re-ranking again ranks all the documents, okay, according to a formula or according to any language model, right? It will again re-rank the for all the queries that I have, all the 16 queries. Okay, so from this I got four queries. Okay, and from this I get four queries. For example, let's say, okay, I got four queries. So now if I re-rank them, then all of this will be rearranged in an order. Okay, in an order. All of them will be rearranged in an order, and then they will be given to the LLM that is here. Okay, so this is the thing, right? To do that, and re-ranking, uh, it's done using reciprocal rank fusion. Okay, reciprocal rank fusion, and that's a proper paper that came up, reciprocal rank fusion paper that came up by the University of Waterloo. So it's a very small research paper, only 2 pages. So they gave a formula over here. Okay, so this is the formula for reciprocal rank fusion. Now I'll take a moment and make you understand what is reciprocal rank fusion. Okay, so now get this. There is an original query that the user asks, and using another LLM, sorry, I'm generating three more of them. Okay, I'm generating three more queries of them, and vector store and everything is being created like doing drag. Okay, now when the user asks a question after simulative search, I'm getting these three results back, ABC, and all of them are ABC. But, but for the first query, okay, for the first query, A is very much important, followed by B, followed by C. For the second query, B is very much important, followed by C, followed by A. For the third, A is very much important, followed by C, followed by B. So it's the rank. So 1 for A, 2 for B, 3 for C. Here B is 1, C is 2, A is 3. Here A is 1, C is 2, B is 3. Right. So this is the results that we got. After that, we'll get the reciprocal rank for them. Reciprocal means 1 divided by that number. So for A, it's 1 by 1. For B, it's 1 by 2. For C, it's 1 by 3. So similarly for all of this. After getting the reciprocals, I'll fuse them together. So I'll add them. So for A, I'll do the summation of all these ranks for A. For B, I'll do the summation of all the ranks for B.
हेलो हाय.
So for B, these all things will be
हेलो.
added.
आवाज आ रही है?
For C, all the C will be
हाँ,
added.
मुझे ये पूछ.
Okay, so this is the fusion process over here. So after adding, okay, 1 by 1 plus 1 by 3 plus 1 by 4, I'm getting A to be 2.33, B to be 1.83, C to be 1, uh, okay, sorry, C to be 1.33. So now the order of importance is A, B,
हेलो.
and right. This is what we got.
हाँ, मैं
So
ये
again, these are
बोल रही
re-ranked
हूँ
once again,
कि
multiple
उसे
queries.
क्या बोलते
Okay, so
हैं.
now to the model, this is the
अ,
order that the documents will be
हाँ,
passed
मैं
in,
ये बोल रही हूँ कि
right?
उसे क्या बोलते हैं.
But
वो
if
जो
you see
ग्रुप
the
बनाया
formula,
हुआ है
it's
जिसमें तुमने
more or
टीचिंग
less
के लिए
same.
डाला था, वो ग्रुप का
It's
क्या
more or less the
मतलब उसे
same. 1
करवाना
by
है नहीं
the
करवाना है
reciprocal
ये
R of
कैसे
D
पता चलेगा.
and the summation. But there is this
मतलब
K
नहीं
parameter
करवाना है
over
तो
here.
हट जाते हैं ग्रुप से.
Okay, so this is kind of to normalize.
अरे वो जो
Okay, in the research paper, they took
नहीं
it to
जो
be
वो
60.
गुड़गांव और दिल्ली वाला था ना जो
Okay,
मैंने
if
ऐड
you
किया
see,
था
they
जिसमें
took
कल कॉल नहीं
where k
उठाया.
equal to 60 was fixed
तो फिर
during
उसका
a pilot investigation and not altered during the subsequent validation. Right. So this is to normalize
तो बता रहा था
uh,
कि हट जाते
the overall thing. Right. So this is how the reciprocal rank fusion works. Okay. So so this is used to generate multiple queries and finally rank all the results that we
नहीं
got.
चाहिए तो
But
ठीक है
so
बेटा
all of
जब
this is there due to time constraint. Whatever I told you, everything is written over here. So
नहीं 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 मैंने
the
बस
the
ऐसे ही
main thing is the
पूछा
disadvantage that
था.
I'd like to
मैंने
discuss
ऐसे ही पूछा था
because
कि उसका क्या
multiple
स्टेटस है.
subqueries
एक मुझे
increase
पता
the
चला है
retrieval
उसका
and ranking
प्रोजेक्ट में
cost,
देख
right?
सकती हूँ.
Require robust query generation because the thing is that it can be used very prettily, very well with a fine-tuned LLM that has the knowledge
कोई
about the
बजट
subject.
नहीं है कि
If
उसने
it does not
स्पॉन्सर
have the
को
knowledge about the
उसको
subject,
वेट नहीं
it
कर
will
सकता
generate
आठ आठ
some
घंटे 4 4 घंटे.
hypothetical queries
आपको नींद
and
नहीं है
then
क्या?
everything will go wrong,
मैं
right?
तुमको हक वक्त पे
So
जाके
if,
मतलब
for
एक
example,
भी तीन
if
चार
I have
मीट भी
a
क्लोज करवा के
financial
दिया
document
तुझे. ठीक है
and
ऐसी कोई
I'll give
नीड नहीं लगी
a
पड़ी.
regular
जब
LLM,
उसको
it
रिस्पेक्ट नहीं है तो
might not
निकलो यहाँ
perform
से.
as well as if I fine tune that LLM on finance data, then it will have a good amount of knowledge about finance and then it can do question generation on the query about financials
बाकी
when the user
मेरे को
asks.
एक डॉक्यूमेंट
Okay,
बनाने दो
so it's like
दो
a
स्ट्रक्चर
teacher
का
who knows,
वो मैं
who
ग्रुप
knows
में
the
डालती
subject
हूँ
very well.
और फिर
And
उसके
if,
हिसाब
for
से काम
example,
कर
I
लेते
am a
हैं.
user, I am going with a vague query
ठीक है और
to
फिर
any
एक
general
रैपिड
teacher.
मीटिंग कर लेते हैं
Okay,
क्योंकि कल तुम
then
रखोगे
the
नहीं.
teacher about, let's say the vague
अगर
query is
आर्यन
about
का
history,
रिस्पॉन्ड नहीं
and I'm
आता है
going to a
छह सात
primary
बजे
school
तक
teacher
तो फिर
whose
उसके
teacher
साथ
is
मीटिंग
like
नहीं
every
करेंगे
subject.
क्योंकि फालतू
So
टाइम नहीं है.
that teacher will not be able to give me that much of new questions. And if I go to a high school teacher who properly only teaches uh, history, that teacher will give me more amount of in-depth questions as compared
दो
to that
हफ्ते.
primary school teacher because his specialization is history. So similarly, if I am getting a model about financials, right,
तो
which
मैं वही
the
कह रही
model
हूँ
is
ना.
fine-tuned on finance data, then it can generate better queries related to finance field.
मेरे को बिल
So
करवाना ही
that's
नहीं है.
that is one of the major drawbacks of RAG fusion. That if the model will not have ample data, it might hallucinate and it might give
तो मैं
some
वही
bad
कह रही हूँ ना पहले उससे वो
sub queries
कंफर्मेशन
that
ले
will
ले
be
उसका
generated.
क्या आता है. ऐसा ना हो
Right.
कि
So
पूरा
these are the
टाइम
main
देके खराब हो
disadvantages.
जाए.
And if you
मेरे
go
पास बस टाइम का
to the
शॉर्टेज है
reciprocal
वरना
rank
अब
fusion
वक्त
that
मैं
I
भी हैंडल कर
spoke,
लूँ.
this is the entire thing.
ठीक
About
है.
that, the
तो
definition
मैं
and all.
एक वर्कफ्लो बना
And
के डाल
if
देती
I
हूँ
go
वो
to the
अगर
code,
अप्रूव कर लो
just
तो वो भी
finish it
समझ में आ
quickly because
जाएगा
I
और
have
फिर
one
उसमें
more
डेली
left.
चेकलिस्ट बना के स्टेटस
RAG
अपडेट
fusion.
डालते रहेंगे और जो काम नहीं करेगा उसको ठीक है. ठीक है. बाय.
Yeah. So here I am using PyPDF loader to generate, like I mean to load this, you know, what you call is PDF file. This is a research paper, and I'm splitting it with a chunk size of 500 and the overlap of 100. And I've splitted all of this, and I'm using this embedding again and Chroma DB for that, and I'm telling it to explain methodology. Okay, it will do similarity search and it will get something. This technique combines element of relevant retrieval and generation, so something like that. Uh, yes. Now what I'm doing is creating a proper model, and then I'm passing it everything, so that because this is just the retrieved document, right? The similarity source one, and then passing it to LLM. So according to provide content, the methodology involves combination of retrieval and generation method. So this rephrased one. Okay. Now I'm using this human message and all of this system message to tell that you have to generate two new queries. Okay. So I'm giving the prompt, the LLM, the output parser over here, and this is some short function that I'm writing to split. And this is the reciprocal rank fusion. So here that is 1 by the rank plus k that we saw in the research paper. This is the formula, and I'm re-ranking that, and I'm getting all of that. So generate query, retrieval map, and reciprocal rank fusion. This function that I'm getting, and the queries explain the methodology. Okay, answer the question based on the following context, the context and the question, then passing over here. So this is the AI message that is being generated. If I do dot content, you'll get the content. The methodology described in the provided context is the use of RAG for summarization and extraction of clinical information. So now you see this very detailed as compared to this previous one. Okay, according to the provided context and methodology in the combination. Now, because there are multiple, like there are two questions right now that are generated. Now it is very much detailed, very much well given to us, right? So this is what is RAG fusion. So multiple query generation followed by reciprocal rank fusion for re-ranking. So this one was there. Now the final one is hide. So this is again uh, uh, a technique, it is called hypothetical document embedding. It is designed to enhance the performance of the retrieval system, obviously, especially for cases where queries are vague, ambiguous, and lack sufficient context. Now, when again the user can give any query. Now, what we are doing is instead of generating multiple queries, what we are telling that, okay, you are an LLM, take this query, take this user's query, generate some hypothetical answer, and then I am comparing the answers embedding with the embedding in the vector store. Now the question is not in the scene itself. Okay, the question just asked by the user. I, as a LLM model, am generating an hypothetical answer, and then after that, that hypothetical answer is being embedded and being searched, and again the retrieved documents are similar, not to the user's query but to the hypothetical answer that is generated. Because if the user query is vague, again the similarity search might not work that well. So what is the thing is, for example, there is this restaurant data. Okay, so I created a RAG so that it can answer about the menu. Okay, so what is the price of some specific thing? What is the what are things are there in the menu? Right. So I created a RAG system. So menu is the user menu is the PDF file or knowledge base that I have. On top of that, I created this RAG system. So the user comes and ask a very vague query. Okay, so for example, what is there to eat today? Okay, or what this restaurant serves. Okay, so now the similarity search might not work that well. Okay, if it's let's say McDonald's restaurant, so Maharaja Mac is there, and all those things are there. So the menu and what is being served today are kind of similar. Okay, but again, getting very well responses might not be possible. But what happens if I tell another LLM to generate the answer for this? Okay, it might not be accurate, right? Because that LLM does not have the access, right? It might not be accurate, but it will tell, okay, it might happen. Okay, this is the answer from the LLM that it will tell that, okay, it might happen because this is a McDonald's restaurant. They are giving some Maharaja Mac today or something like that. Now the word the Maharaja Mac is present in the answer of the LLM. Now, because I am embedding the, the answer from the LLM and searching it will get better results because now the cumulative search will work very much well because now I have some words or some phrases that are actually contextually very much similar to that in the database. So this is the whole concept around HIDE, hypothetical document embedding, right? So this is the what, this is the why, because poor queries, right? The when the query is very short, it lacks clarity and everything is there. Okay. So the disadvantage is if the query is already specific and well structured, generating hypothetical documents may add unnecessary computational overhead. Okay. So there may be some delays, obviously, because there is another LLM that is generating anything. Okay. Here also a fine-tuned model is preferred because if the model will not have knowledge about that restaurant or the film, it cannot generate. Similar to the previous one that we saw. Right. So this is the thing over there. So if you go to the code, you go to the code height. Yeah. So I'm using the PyPDF over here. I tried this with Wikipedia website also did not working. This is the embedding model. This is the Llama 8 billion model that I'm loading. And please answer the query asked by the user. Keep it short and detailed. I'm asking it. So this is the answer generation, hypothetical answer that is being generated. Okay. So whatever the query is being asked, it will give me a hypothetical answer. So I asked it, what are the evaluations things? Sorry, LLM evaluation is my query. Very small, but again it can do a good match. But again, sorry, it is not doing any match. It is just giving me the answer because it is a hypothetical answer that is being generated. So it's giving me all those metrics and all. Okay. Now what I'm doing is I'm getting similar documents with this response. Okay, I'm not using this query. This query is only used to generate a hypothetical answer. Now using this answer, I'm searching for similar documents. Okay, for similar docs, I got, for example, rating RAG can mitigate hallucination by providing access to more data. So all of these kinds of answer I'm getting. And I tried get relevant documents from the user's query as well. Okay, so this is some other thing, 2.3 retrieval augmented generation to enable model to access external knowledge. So it's nowhere close to, rating the models or, evaluating the models. But here is somewhat close, I think. Okay. So it is there, pointing methods and everything. So this is where you can use hide. Okay. So wherever you want to. After that, you can just pass all the similar documents to another language model, and they will give you the answer. Right. So that's how this hide also works. So with this, I'd like to conclude today's session. So thank you so much for joining. And if you guys have any questions,
Hey, Satyajit, thanks a lot.
yeah, thank you
So
so
I
much.
think we already over time. So,
Yeah,
it okay? Like we've been in touch on LinkedIn.
sure, 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 Neeraj.
Yeah, get it. I'll ask questions if I have anything.
Sure,
So
sure,
thanks
sure.
for sharing the code also. That will be
Thank you
very
so
helpful.
much. I'll also share this PPT in the same repo that I have
Okay,
over here, along
cool.
with all these, things that I showed you.
Okay, thanks a lot.
Thank you.
I think we'll just open up the floor for Q&A. If anybody if anybody has any questions, you can ask it now. And yeah, I think Satyajit will be happy to answer.
Yeah.
So I have one question, like on these tools, the last two methodology which you have talked about. One is we generate a query, and another is we generate the hypothetical answer. Then we get the data.
Yeah.
Which one works better in which situation? If you have some information on that.
Well, I have not used them extensively, to be very honest. So it depends on the use case. So there is something called RAG evaluation as well. So there are a lot of things like ragas is there, what is there. So you have to check that which one works well in each scenario.
Okay, okay, fine.
Yeah,
Thanks. Yeah.
yeah, welcome.
To the world of AI and chatbot development. Whether you are a beginner or a tech enthusiast, you are in the right place. It's a pleasure to introduce our speaker Satyajeet Narayan, an expert in AI and chatbot development. He has extensive experience in RAG and will guide us through this exciting topic. Let's give him a warm welcome. Over to you, Satyajit.
Satyajit, you are on mute actually.
Oh, sorry. Thank you, Neeraj. So thank you, Simran, for this warm introduction. So without any further delay, let's start the session. Okay.
Just allow me a second. Yeah, so good afternoon, everyone. Welcome to today's workshop on Advanced Retrieval-Augmented Generation. We are excited to dive into the world of AI and chatbot development. Whether you are a beginner or a tech enthusiast, you are in the right place.